This is for chapter 10 for statistic class. We will combine chapter 10, 10.1 and 10.2 in this section. So, but you do have to do two homework, one for 10.1 and one for 10.2. 10.1 is correlation, 10.2 is for regression. So the first question is asking us if you go to page 483 in your textbook, question 4. So this is question 4 in your textbook. They give you 5 graphs or 5 scatter plot in this case, and you need to figure out which are your correlation coefficient match with this. So the first graph 4a, this graph looks like a perfect correlation. The reason why is because all your points are lining up on the same line. So if they are perfect, then your answer is either 1 or -1. Since this line is, the slope of this line is going down, so your correlation in this case will be -1. So for the first graph, your correlation in this case will be -1. Now let's look at question B here, 4b. This graph shows a positive correlation because your slope is going up. You notice that this graph, the points are a little bit far away from, if you draw a line, this is the line that you would draw right here. So there are a couple 3 points here that is far away from the line. So your correlation will be a positive but kind of moderate. So in this case, it will be 0.746. So for question B, your correlation in this case will be 0.746. For question C, this graph shows pretty much scattered here if you compare to this 5 graph. So that means the correlation is pretty weak. That means the value is very close to 0. So based on this 5 correlation, it should be 0.268 because that is the smallest one. So for C is 0.268 because that correlation is close to the smallest, 0. Question D, this looks like a positive correlation. However, there are some points, not a lot of points, are very close together to each other. It's not perfect, but it's close to perfect. So your correlation in this case will be 0.992. So it's kind of close to perfect in this case, because 1 is considered perfect. And the reason why it's positive is because your slope is positive. And for E, this graph shows exactly a straight line. So when it shows exactly a straight line means it's a perfect, they all line up in a straight line. So, and it's a positive, so your correlation in this case will be exactly 1. So this is usually how you figure out correlation if I give you a scatter plot. So this is how we do this question 4. Now let's talk about question 1 here. In your notes, it says that let the predictor variable x be the first variable, and given the data, find the best predicted value of the response variable. Use a 5% significant level. So height, width, and weight are measured from 20 randomly selected bears. The 20 pairs of measurement yields the mean of this 69.6.9 inches and the mean weight of 85.93. The correlation coefficient is 0.879 and the p-value is 0. And the regression equation is y hat equals to -2.12 plus 61.9x. Find the best predicted value y hat weight given a bear with height width of 6.5 inches. So every time when you guys do these kind of questions, the first thing you guys need to know is what is your x variable and what is your y variable. Since this question is, if you look at this, find the y hat, that is the weight. So that means that your weight will be your y variable, your x in this case is your height width. So this is very important in this chapter 10 section, is because if you did not define what is your x and what is your y, your answer will be wrong. That means you will get totally wrong answer here. So if you switch your x and y around, so that's why you need to know which one is x and which one is y. So in this case, x is your height width because it's given us that your y height here is weight. Okay, so so this mean height width is your x bar. So we know that x bar in this case will be 6.9 inches. And your y bar, which is the weight of the mean weight of the bear, is 85.93 kilogram. So it's given us this, and it's given us that your correlation coefficient R in this case is 0.879. P-value in this case is given as 0. And then the regression equation is given as that y hat equals to negative 212.61, 212 plus 61.9x. Do not forget that every time when you give me equations, you need the regression equations, you have to give me the hat. Without the hat, you won't get the full points in your test. So this question is asking us to find the best predicted value. So if you look at the notes, in order for us to find the best predicted value, you have to go through these three, or we call it prediction. We have to go through these three requirements here. If these three requirements went through, then we call that as a good model. So if it's a good model, then you plug in, you substitute the x into the equation. So if you go through these three and you find out that this is a good model, then you plug in x as 6.5. So it's given us that the x in this case is 6.5 into this equation if it's a good model. If it's a bad model, so what happens if it's a bad model? So a not good model, if it's a not good model, then we will use y bar. So if you find out that this is not a good model, then 85.93 will be your answer. That means you do not need to substitute in. So what are the three requirements here? The first requirement say that your scatter plot confirms your regression line. So if you have a raw data, then you can draw your scatter plot out and make sure your scatter plot shows a linear line, or sometimes we call it linearity. So if your scatter plot shows linear line, is considered it shows that means you pass the first step. So remember the scatter plot we just did. We have some examples here. All 5 of these scatter plots shows linearity, including C, where you know that C is 0.268, very weak in this case, the correlation, but it still shows a straight line. What will not shows a straight line, or what will not shows linearity, is if you draw a graph and that graph is a non-linear case. So if you have like a parabola case like this, or if you have a exponents case like that, exponential case like that. So if you have this kind of cases that is called a parabola or exponent, then we call this as a non-linear case, and that will not fulfill A. Okay. So for this question that since raw data did not provide to us, so the scatter plot shows linearity will be skipped. So this is what happens when since this question did not provide us, we will have to skip this, or we just say it is assumed linearity here. So so what I can tell you here is, if a raw data like this question did not provide to us, then you either skip the steps or you just assume that the scatter plot shows linearity. Now we go through the second step. The second step says that your R indicates there is a linear correlation. How do we figure out if there's a linear correlation? Your p-value is less than or equals to alpha. So in this case, this is step 1. This is the first step. Step 2 is you want to figure out that your p-value in this case is less than or equals to alpha. But what we have in your p-value in this case is 0.0 actually, because the p-value is 0. And your alpha in this case, if you read the question, we use a 0.05. So alpha in this case is 0.05. And since p-value is less than 0.05, so this so you fulfill the second steps, which says that there is a linear correlation here. So this case will say there is a linear correlation. If the question did not provide us alpha or significant value, we always use 5%. Okay, and let's take a look at the. So this means that this is skip or assuming. This is good because this shows a linearity. And the third step shows that your data doesn't, your prediction doesn't go beyond the scope of your data, or sometimes we call the word extrapolation. So how do we find if your prediction doesn't go beyond it? is you look at what number do we plug in. So since this question we plug in 6.5, then you need to do this formula is 2 times mean of x. So, so if you have mean x, our mean x in this case is 6.9. So if you take 2 times 6.9, this will give us, let's see what we have, 2 times 6.9, 13.8. That means that if your prediction is between 0 and 13.8 for your x values, that means that there is no extrapolation. Since our x value in this case is 6.5 given to us in the question, that means that this is no extrapolation. And the meaning of no extrapolation means is that it's good. So right now, the first requirement we assume step 2 is good, step 3 is good. So what is telling us that since this step 2 and step 3 is good, so this is actually a good model. Again, if one of these steps or one of these requirements is not fulfilled, then it's a bad model. Then you have to use the y bar. So since this is a good model, so you can use the y hat using this equation, negative 2.12 plus 61.9 times with x. X in this case is 6.5. So you can use a calculator to figure this one out, or you can use R here. So negative 212 plus 61.9 times 6.5. So your prediction value in this case, something is wrong here. Let's do it again, because something is wrong in this case. Should be 61.9 times 6.5 minus 212. Okay, yep. So your answer in this case is 190.35, and don't forget the units. So this is weight, and weight is measured in kilograms. So this is kilogram. So so this is a good model. So we plug this into your regression equations, and that will be your answer. Again, if this is a bad model, okay, then your answer in this case will be y bar, which is given to us 85.93 kilograms. So make sure you guys know when it's good or when it's bad. Again, this is a good model because we fulfill all these 3 requirements. If one of these requirements is not fulfilled, then it's a bad model. We have to use a y bar.